Seventh grade science crew.
Okay, so in class today we talked about tornadoes and we mentioned something called Tornado Alley. And so in Tornado Alley, if you look on the map, it is about halfway between the poles and the equator. And it creates like the perfect conditions for this type of storm. So in order for a tornado to form, you need a cold, dry air mass, so continental polar coming in from Canada, and then you need a warm, moist air mass. So you're getting your maritime tropical air mass from the Gulf of Mexico. And as we've talked about, and you've probably started to make connections, whenever you have two air masses that meet and create a front, a lot of times you do get storms. Well, unfortunately, with these two air masses, you're creating the perfect storm to create a tornado. So, as a tornado forms, you have evaporation that is causing this cloud to form. And as it forms, it's oftentimes going to be a cumulonimbus cloud, and that's your storm cloud. And it's gonna form upwards. And so you're gonna have all these like frozen ice particles at the top of the cloud, and then as you go down lower, you're gonna have that warmer air. Now, whenever a tornado comes, you get an intense cold front. So I know growing up in western Arkansas, you always got a little uneasy whenever it was stormy outside, and it wasn't uncommon for the temperature to drop 20 or 30 degrees within an hour, creating the perfect conditions for a tornado. And so this cloud is forming. You have the rotation in the air, and it makes this cloud unstable air, and it's going to start to spin and rotate, and it's going to form one of those funnel clouds. And once this rotation hits the ground, a tornado is formed.
All right, guys, as you are studying extreme weather, you might have the question, what exactly is a tornado? I know that we can look in the sky, if we've all seen Twister, or if we've seen different weather channels, we know that it's like this swirling kind of funnel come from a cloud, but let's dig in a little bit deeper. A tornado is violent, and it's a rotating column, so it's vertical. It's a violent column that has rotating winds, and it often comes from a thunderstorm. The most violent tornadoes are capable of tremendous destruction, and it can take away cities, it can take away neighborhoods in a very short period of time. It might go on the path and hit one person's house with another house standing still with not a brick moved. So tornadoes are very unpredictable as far as where they're going to move on their path, and they can be quite dangerous and really terrifying. They can be about as miles long, so they can be like super crazy wide and super crazy tall and move extremely fast. There's a portion of the United States of America, if you're in Miss Cousins' class, you know about this already. She's talked about coming from Tornado Alley. So in the Midwest of the United States, this area is very flat, and it makes it really easy for those winds, those air masses coming up from the Gulf of Mexico and coming down from Canada to meet and create these really vicious tornadoes. And so when you live in what they call Tornado Alley in the Midwest, you see them quite frequently all throughout the year. So in average, there's about 1,000 tornadoes reported each year just in the United States. So tornadoes are super vicious, they're really intense, they can be really short or they can be really long, and they're extremely unpredictable and can cause a lot.
More here. I am here to tell you today about funnel clouds. So a funnel cloud is a rotating cone-shaped cloud that is extending downward from the base of a thunderstorm. Now, some of you might be like, Miss Moore, that is a tornado. No, it is not a tornado until that funnel cloud touches the ground. As soon as it touches the ground, that is when we start calling it a tornado. Some of y'all might be wondering, well, how do tornadoes stop, Miss Moore? It is not fully understood how tornadoes are stopped.
Our weather tools is called a barometer, and if you guys will remember, we did a lab that sort of simulated what a barometer does, and that was the lab with the candle and or a vase, whatever you had. So you lit the candle on fire, you had the water on the plate, we put food coloring in it so we could see it better. We lit the candle, we put something over the candle, and the water filled up, and that's because the air pressure has to equalize. Barometers are used to measure air pressure, and we can do other things with them, like it helps us measure the height above the ground as the air pressure changes. Pilots use it in their planes, and you can also use it to help predict the weather.
Which day of the week has the most powerful gust of wind?
I don't know, what day?
Wednesday.
Why is it so wet in England?
I don't know, why is it?
Because the Queen reigns over them.
Welcome and namaste. I want you all to come and enjoy yoga with me. We will visit everything in the atmosphere, starting with our basics in the troposphere, because that's where basic yoga begins. As you work your way up through the levels, view it like you view the atmosphere. So the next level, which is a little harder, would be up in our stratosphere. That's where planes like to fly. And we'll do movements like the jet stream, going in and out of the troposphere. The next layer is going to be the mesosphere. This is where you will feel your muscles just burning up like meteors as they enter through the mesosphere. After that layer, you reach high into the thermosphere, and this is where our hot yoga begins. It will be humid, there will be much water vapor in the air, and it will be intense, but I know that you can do it because yoga meets you where you're at. And our last layer, the most difficult layer to be in, is the exosphere, and this is where mind, body, and spirit come together to exit out into outer space. Just like the last layer of the atmosphere. And I hope to see you in class. Namaste.
Man, this storm is really coming fast, Brooklyn.
I know, it popped up out of nowhere.
It really did.
I mean, I feel so unprepared. Like what do we need?
Well, I really think we need to first find a bunker, somewhere to go, seek shelter in.
Yes, definitely.
I think we definitely need to make sure we go pick up our rain gauge. We got to go to that weather garage.
Yes,
Right now,
yes.
it's super calm with this high pressure system, but you know that low pressure is going to be coming in fast. Do you
Exactly.
think we need anything else more?
Oh, yeah. We need the barometer. We need to be able to check the air pressure as we're going through this stuff.
Yeah. So
We
we've got-
definitely need the wind vane because we need to know how fast our winds are blowing, just in case we can't drive anymore. Because if the winds get too powerful, it might blow our car over.
Yes, 100%. And then, oh my gosh, we need an anemometer too. I don't even know where mine is.
I think that might be in the garage with all of our weather tools that we got to get as we chase these storms.
Yeah. Okay, let's head to the garage. I think you got to make a left down this road.
Oh, guys, do you hear that alarm?
Oh my gosh. Is
That
the
means it's
coming?
on the radar somewhere. We better hurry up and go get our materials.
7th grade science crew.
7th grade science crew.